Hello and welcome to Vincent Codes Finance. In this video, I'll show you how I use Git and GitHub to manage my research projects and make sure that I keep track of all my changes. Git is a version control system that is an essential tool for all serious developers out there. It helps you keep track of changes to your code, but I don't use it only for code because in my research, yes, I do use code to analyze data, but I also use Git to keep track of the changes to all my writing because I use Tech and Quarto for my writing, so it's all text-based. It's basically code, so I can use Git to manage that as well. And when you're serious about using Git, it becomes even more powerful when you host your repositories on GitHub and you use all their additional features that they provide to foster collaboration and project management. Git is the most widely used version control system out there. You can download it for free. It is open source, so it's available for any platform you can think of. You can download it and install it easily on Mac, Windows, Linux. If you're on Mac, I recommend you installing it with Homebrew. And then you'll also need a GitHub account, so you can go on github.com and just click on sign up there and create your first account if you don't already have one. In my case, I do have one, so I will sign into my account. The last thing I like to install, even though it's not required, you can always use Git directly from vscode or in the terminal. I really like having a UI, so for that I use GitHub Desktop. It's free as well and integrates super well with all the GitHub ecosystem, so you can just download it for free and install it. The first thing you'll want to do when you create a new project is create a repository, so you can create one either by going to new here on the left-hand sidebar or looking at the plus sign here, you can create a new repository. When you create a new repository, you'll have to choose a few things, including the project name. So the repository name, it's not that important, except that it will be the default directory name for anyone cloning your project, so all your collaborators. So it's a good idea to have a kind of good name for that. So in this case, I'll have a test project. We'll see that the name is available. Now I'll make my project private because I'm working on a new project. I can always change it back to public later. I'll also want to add a README file. So this file is going to be the description for my project. And I'll want to add a git ignore file. So in this case, I will be doing some Python. So I'll use this template here. And I also want to include a license for all my research projects. When I want to distribute them, I want the really permissive license, the most permissive license that I can get. I think in this case, MIT is a good choice, Apache license 2.0 as well, and the BST3 would be a good choice as well. So I'll go with the MIT license. It's the most permissive in my opinion. So now we have our repository. It is created. We see that we don't have much here. We've got a license, a readme.md file, and a git ignore file. So now when I want to import this repository on my machine, so I can click on code here to get the link to the repository. So I can use that to clone my repository on my own computer. Or because I've got GitHub Desktop, I can click on this and open GitHub Desktop. It's an even easier UI to load my project. And now it will ask me whether I want a clone on a local machine, and I will say yes. The reason why I want to use GitHub Desktop is because it makes all my workflow really easy. Now I can just click on open in Visual Studio Code and it will open my project. I will change to my VCF profile and now here we go. We've got our project ready to work. Okay, so now I've got my project open. So the first file is the git ignore file that was generated by GitHub. I will typically want to replace this one by one generated by gitignore.io, which is much more comprehensive. I think the templates that this website provides are better than the one that GitHub provides. So in this case, I have a project that does some Python. I'm working on Mac, and I will also be doing some LaTeX here. So I can just create my file, copy and paste all of this back in my gitignore file. So now I'm all set up. These gitignore files, what they contain are patterns, and all of the files that match these patterns will be ignored by Git. Typically what you want to exclude are all the temporary files, the build, so the executables, and the output of your projects, because these you don't want to commit them to your repository. They're not required in order to keep track of your changes. All you care about is your code, because you can always regenerate those. I also try most of the time to exclude all my input data from this from my Git repository, because if files are large, then they tend to kind of slow down a bit the repository and Git in general. It's just better practice to exclude them unless you really want to keep track of those changes. And ideally, I only include small files that are really small. There are other alternative systems to manage versioning of files when we're dealing with data that are much more efficient than just pure Git. Next, we've got our license file, and finally, we've got our README. The README is what shows up on GitHub when you load your repository. So it will be kind of the main welcome page to your project. That's where you would say have a little bit about usage, info for my project, and other like project description and things like that. I use the readme.md file for this. So it's a pure markdown file. I find that much more convenient. So now I've made a little change. Suppose that I wanted to create a new project. I might create a new folder. I would call it, I don't know, source. I'll put my file here. I'll maybe put one file that would be project.py. And here I might want to generate all the dependencies for my project. So using poetry, so I would do poetry init. It will be test project. I'll just go with the basic everything with this. And I don't have any dependencies right now. So I'll just create this. And now I would do poetry installed. No root. I don't want it to be installable. Oh, I got a typo. Let's change that. So now I've got all my dependencies created. I've got my virtual environment created. So my project is good. Let me put a just simple print hello here in my script. So now my project is all created, but nothing will appear if I go on GitHub. Even if I refresh, I haven't sent anything to my project. Okay, so how do I do that? Well, for that, I will manage everything in this source control tab. Right? So here what I'll see is I'll see everything that I have done since the last commit. The last commit was the first one when the repository was created. So a commit is kind of a snapshot of your repository. So here we can see that there have been 5 changes since the last commit. So I've modified my gitignore file. If I click on it, I'll see all the changes. There's plenty of them because I just almost replaced the full file. There are also U. So here those are, this is U for on stage, so or on track, sorry. So these are files that are not yet tracked by Git because I haven't added them yet. There's the README here. I added a few things. And then there's my project py file that I've added as well. So README and gitignore, they've got a M for modified, and the other ones, they're U because they're currently on track. So if I wanted to just commit all of these changes, well, I just need to stage them. So with the little plus sign here. So now they are in the stage area. And that means that when I commit something, when I do my next commit, all of these changes will be committed in that commit. But say before I wanted to just create this new file, this new code file, before maybe I just wanted to complete the setup. So this would be one commit, right? One set of changes that I want to put together. So here I could have a new set of changes that would be, could be complete setup. And now I commit. So it is committed. So I've made a snapshot of these changes, but they're not yet on GitHub. If I go to GitHub and I refresh, they're still not here. Okay, so how do I put them on GitHub? Well, we see here, it is, I've got something that showed up as incoming, outgoing. It says for main, this is the current branch I'm working on. So by default, I will be on the main branch. So that's the main kind of working copy of my project. If I want to upload it, I can just come here and do a push. Before doing a push, typically it's better to do a pull first. So the pull will contact GitHub and pull all the latest changes that are on GitHub in that repository. So now I know that my project locally is up to date. And now if I want, I can do a push. And now my changes will be synchronized on GitHub. So if I go on GitHub and I refresh, I'll see that these changes have been applied. But not the project.py file. It's still not there because I didn't add it. So now I could do a new commit. I need to change to stage this change and added new file, for example. So all of these commit messages, they're useful for you when you look at the history of your project to kind of figure out what each of these commit is adding to the project so that when you go back, you can look at all of these steps. And now because I'm done with all these changes, vscode will also put me a new button called sync changes to let me know that I can just sync and everything is good. So that's how you commit changes to your repository. If we look at the files that we've added the poetry log version. So this one really keeps track of all the dependencies of the project. The recommendation from the maintainers of poetry is that you include this log file into your Git repository, unless you are writing a repository to distribute code publicly, distribute packages, in which case you would not include this log file. So now maybe there's many of us, or even just me working on this project, but I want to try something. I want to make a change that might kind of break the project. So I want to kind of create a new version of the project. A version that I'll be working on, just trying out something. If it doesn't work, I'll drop it. If it works, I'll bring it back to my main project. So for that, I will use a new branch. I'll click on main, and then I'll create a new branch, which would be, say, new feature. So now I see that you can see I'm working in that new feature. So I'll create a new file, feature.py. And here maybe print even better. Hello, new feature. So now I've got that. Can work. I can save it. And maybe I want to work a bit more, and I want to keep kind of snapshot of that work. I can stage and commit this new feature. So new feature. Got a commit. Now it will ask me, do I want to publish my branch? If I publish my branch, everyone who has access to the repository will be able to see my branch. Maybe I want to keep working locally before making it public. Maybe I'm ready or not. Let's wait a bit. But the nice thing is that if, say, I have to pause working on this feature, I have to go back to the current version of the project because we need to run a quick test or something like that, then I can always go back here and switch to main, and now we'll see, right, this new feature, well, the file isn't there. VS Code will tell me. If I go back here, it's not there, right? Because now we're kind of on the main branch. So we are on the current version of the project, but I can, after that, come back to new feature, and voila, my feature.py file is here. So everything's good. Now say I'm happy with this new change. What I will do is publish my branch so that my colleagues or co-authors can see it. And now once it's been published, I can push, I can pull. I can see now if I go back to GitHub, if I refresh now, we've got 2 branches. And one of them had a recent push 13 seconds ago. Right? And suppose I'm happy with this branch. I can come here, go on compare and pull request, and open a pull request. So now the name is a bit confusing because it's not really related to the push and pull that we've seen earlier. A pull request is you requesting your new branch to be pulled into the main branch or another branch, but say in this case that would be the main branch. So I'm asking GitHub to take my branch and merge it, pull all of these changes back into the main branch. So here it could be, for example, here the title would be by default new feature because that's what we had in the commit. I could add a description for this kind of new feature. I've had it, really cool feature, fixes our issues, blah, blah, blah. And now I could also ask for reviewers. So if I've got co-authors that I've been added as collaborators, so in order to add collaborators, I would go into settings and invite my collaborators. If I've got some now, I can ask for reviewers. In this case, there's none because I don't have anyone here, but they would receive an email and then be able to see your pull request. And then they would be able to comment and look at all of these things. So now say I create that pull request. It's going to show up here in pull request. I can see this pull request consists of 1 commit. The file changes are there. And here I can come up and add a little comment here for my collaborators to see. And we can ask review, have general comments, and when we can have a conversation on all of these changes. And when we are happy, we can either close the pull request without merging, or we can come here and merge the pull request. And now once that's done, it will be merged. It will ask me to delete my branch. I can do it safely because all my changes have been put into main. So now my branch is deleted. Can go back here to my code and everything is here. There's only 1 branch left. And here we can see all of these commit messages. They are here. So here in this column, GitHub will display the last message from the last commit that affected that specific file. So here we can see that in this folder, the last commit was 4 minutes ago. And we have these 2 files. So this file wasn't affected by the last commit, but this one was. We can also always go back to all our commits. So now we have 5 commits already. So we can go and look at these and see what each of these kind of brought in terms of new files that were added or changed. Plus, I know also who did that commit, so we can see who was to blame if there's any issue. And now if I come back here, I can pull my changes and now I'll see, oh, couldn't find the remote new ref feature. That's okay, right? It's because we didn't, it doesn't exist anymore. We've already deleted that. So we can go, here in our source control and delete that branch. Now I'm missing a few things here. So what I'd really want, ideally, is to have all of these additional features that you can get through the extension in vscode. So for that, I will need GitHub pull request. So this one is already installed. And you can have GitHub repository, which is good. GitHub has a lot of different features that are available by default here. And And another one that is super popular is called Git Lens. So this one will install a lot of different features that are associated with Git. So this is another useful one. Once you've got all of those installed, then you also have a little bit more things here. So you'll see your list of commits. You'll see your branches. So now I've got main. So I need to pull this one. I will pull these two commits to main. So now main is up to date. So now suppose I'm ready to delete this branch. I can come here, switch to main. Now here I will be able to delete my branch. So I will delete branch new feature. The last thing that I want to show now is that Git is actually really good at dealing with conflicts. So now I've got a new feature file here. Suppose that I want to add a few things to that code file. So 1 + 1, for example. I'll even make a is equal to 1 + 1, so it actually does something. So suppose I've made a change here, and one of my co-author, or even myself on a different machine, I could have come here and taken this feature file, and suppose I just edit it here, and I have, say, b is equal to 2 - 3. I'll commit these changes, so I've made a little change here. If I go back here, so the change now is on GitHub, but it's not on my local machine. So if I come back here in my source control here, I commit this change to in my local machine. So update here, I can commit it. And now say I want to sync my changes, click OK, I will get a message. So I will get an error. So I could open git log and it will tell me there are some conflict. So now I'm stuck. There's not much I can do until I resolve this issue. So what I can do now is pick the file that I want. So in this case, I would go here to my terminal and I can set how I will use this. So I could, for example, use a rebase or not. In this case, I will do rebase false, git pull. So now the merge issue has been identified by vscode. I can just click here on my feature and see what I want to keep. So I've got either this that I can change or the incoming change. So this is the current change. So this is what I've done. Incoming change, that's the one that is on the server, the one that I did directly on VS Code. Or I could accept both or compare the changes. So in this case, maybe I want both. So I will accept both and they will be all both there. I can save and then I will stage that merge commit and commit it and then sync it back. And now if I go back here on my GitHub, I will see that both changes are there. So I have been able to merge all of these conflicts. So this is super powerful. Ideally, you don't want to have to deal with these merge conflicts. So whenever you are working, it's better to work in a separate branch and merge back your changes. So that avoids kind of these conflicts. But sometimes we do have conflicts, and this is a really useful thing to have. So that's a little introduction to GitHub. I hope you found that interesting. Obviously, there's a lot more features that I want to introduce to you in future videos. But in the meantime, I think this is a good introduction. If you are a student or an educator, I strongly suggest that you head to education.github.com and sign up for a student or educator account. This will give you a lot of free benefits, including GitHub Copilot, their AI assistant based on ChatGPT. So that's it for today. I hope you enjoyed this video. If you want to learn more about how I use Git and GitHub for research, have a look at my blog post. The link is in the video description. And if you enjoyed this video, please like and also consider subscribing to the channel so that you are notified of all my upcoming videos.